Hello students, today I am going to take a class of linked list in your data structures class. So, we start with a new topic, linked list. As I have talked with you all in the previous class that linked list is a linear it is an example of linear data structure, and just like arrays, linked lists are also very important. So, as the definition goes, it is a linear collection of data elements called nodes pointing to the next node by means of a pointer. So, basically in arrays also you are storing homogeneous elements, and in linked list also it is a collection of homogeneous elements, but here the data are arranged in the form of nodes. So, we have nodes and the nodes are interconnected to each other by means of a pointer. So, it is the second most used data structure after arrays. So, after arrays you will see that linked lists are the most used data structures, because the advantage of linked list is here is that the elements need not be at contiguous locations in the memory, and hence you will see that in certain ways linked lists are better than arrays. So, when we talk about linked list, you will see that there are the three things that we are going to discuss. One is the link or the node. That means each link of a linked list can store a data called an element. So, in the node you are going to have two fields. One is known as the link field or the node field, which is going to store the data which you are going to call as an element, and you have a next field which is the pointer field, and which will contain a link or a pointer to the next node in the linked list. And first is actually just a pointer or a connection link to the first node in the linked list. So, this is the pointer that allows you to access the linked list, the first pointer. So, this is the example of a linked list. See, the first or the head node is pointing to the first node in the linked list. The first node is having two fields, one is the data field and the other is the next field. The data field is holding the element A, and the next field is holding a pointer to the element B. Now, let us compare linked list and arrays. So, if I compare linked list and arrays, you will see that both have their own advantages and both have their disadvantages. So, they first of all, both of them are linear data types, and they can data structures, and they hold homogeneous elements. So, the advantages of linked lists are that in the case of arrays the size is fixed. So, at the time of declaration of an array, you give the size of the array, or if the size is not defined, then at the runtime whatever elements you store in the array, those number of elements define the size of the array. While in case of linked list, you do not have to need to know the size of the linked list in advance, because it is a dynamic structure. So, the number of elements will, if you increase the size of the elements, the size of the linked list increases. If you decrease the elements, the size of the linked list decreases. This is because we do not need to store the elements of a linked list at contiguous locations in the memory. Hence, I do not need to reserve anything in advance in the memory. Like in an array, if we are having 10 elements, and if the elements are integers and each integer is occupying a space of 4 bytes, then 40 bytes contiguous memory locations are required, 40 byte block is required for an array, but that does not happen in a linked list. That is why they are dynamic in nature. Then second advantage of a linked list is like insertion and deletion in a linked list are very easy, because when you are inserting elements or you are deleting elements from a linked list, you just have to change the value of pointer variables. So, in the next class I will show you how you are going to insert and delete elements from a linked list. While in arrays, as you have seen in my previous lecture, when you delete an element or you insert an element into an array, you need to shift the elements, and this shifting operation, as I told you, when we implement shifting with the help of the hardware, it becomes a very expensive operation, because you need to create room, hence you are shifting elements, and therefore insertions and deletions are not very easy in an array. So, if you are managing a data structure where the elements are constant, but you need to perform certain operations, like you need to sort the elements, then it is preferable to store the elements in an array. While if your operations are mostly insertions and deletions, that means your list is changing continuously, then it is better to manage your list in the form of a linked list. So, basically two advantages you can see, the dynamic size of a linked list and there is ease of insertion and deletion. Now, but there are certain disadvantages also of a linked list, like in a linked list random access is not allowed. We have to access the elements sequentially starting from the first node. Hence, we cannot perform binary search in a linked list. So, if you want to search an element or you want to sort the list, then it is better to use arrays, because binary searching is not allowed in a linked list. And second disadvantage is that linked list we are maintaining with the help of pointers. So, you require some extra memory to hold these pointers. So, these are the two disadvantages of a linked list as compared to arrays. Now, the types of linked lists that you are going to study are three types. You have a simple linked list, you have a doubly linked list and you have a circular linked list. So, in this lecture I am going to tell you about, we have just seen a simple linked list. So, we are going to now, I am going to talk about a doubly linked list and a circular linked list. But in your syllabus, all the insertions and deletions we are going to study with the help of a simple linked list only. We are not going to deal with doubly and circular linked list, but yes, I am definitely going to define and I am going to tell you the applications and advantages of a doubly linked list and circular linked list, and I am going to show you the diagrams. So, these are some of the basic operations that we are going to study for a simple single linked list, which is insertion, deletion, displaying the elements, searching and deleting. So, this you are going to do with the help of a simple linked list. So, this is in this slide you can see a doubly linked list. So, when I say a doubly linked list, you will see that in the previous singly linked list we had only one arrow, that is the next field, which was pointing to the next node in the linked list, and hence you could only move forward, you can navigate only in the forward direction. While in a doubly linked list you will see that you have two fields, one is previous and the other is next. So, each node will now consist of three fields. One field is going to hold the data, one is going to hold an arrow which is called as previous, which is going to point to the previous node, and the third field is the next field, which is going to have a pointer to the next node in the linked list. Head is again taking you to the first node. So, you enter your linked list with the help of the head pointer, and the last node has the next field as the null pointer. That means, it is not going to point to any node since it is the last node in the linked list. So, the advantage of a doubly linked list is you can move forward as well as you can move backwards. Okay. So, in a doubly linked list you will see again I told you that you have a data field, you have next field and you have a previous field. So, this is what is given in this example in this slide. Now, what are the advantages over a single linked list of a doubly linked list? So, as I told you, you can traverse in both forward and backward direction. The deletion operation in a doubly linked list is more efficient, because the pointer to the node has to be deleted, and whenever we delete a certain node we need to know what was the previous pointer. So, previous can be easily seen from the doubly linked list since you have a previous pointer, while in a singly linked list we need to search for that previous node and allocate the address again. So, it takes time in a singly linked list. Okay. So, this is the advantage of a doubly linked list. Now, in this slide you can see a circular linked list. Now, a circular linked list means when it is in the form of a circle, that means my last node is connected to the first node. So, if I connect my last node to the first node, as you can see in the diagram, it forms a kind of a circle. So, in a circular linked list, if the header pointer is going to tell you which is the first node, so you can actually change your first node and you can traverse the whole list, and you will know that you have reached the first node if you revisit that node. So, this is the advantage of a circular linked list, because directly from the last node you can reach the first node. Now, in this diagram it is you can see that it is a singly circular linked list. That means, you have only one pointer field which is pointing to the next node in the linked list, and in the last node, which is marked as 10, you can see that it is holding a value of 10. The next field is, instead of being null, is pointing to the first node. So, this is an example of a singly circular linked list. You can also have a doubly circular linked list. So, as you can see in the diagram, here you have both the previous as well as the next pointer. Now, in the last node the next field is pointing to the first node and the previous field of the first node is pointing to the last node. So, it forms a complete circle, and this is an example of a doubly circular linked list. Now, let us see what are the advantages of a circular linked list. So, in a circular linked list, any node can be the starting point. We can traverse the whole list by starting from any point, but we just need to stop when the first visited node is visited again, then we will know that we have again reached the starting point. So, circular lists, they are very useful in applications to repeatedly go around the list. For example, in the operating system, when you are running a number of applications on a PC or on your CPU, it is common for the operating system to put the running applications on a list. So, the list that they maintain is a circular linked list. So, that here what happens is they are going to give a processor time. So, starting from the first node, maybe 5 microsecond per program will be given or per application will be given. So, when that 5 microseconds finish off, you go to the second node, third node, last node, and again come back to the first node. So, the operating system is easy for the operating system to track if it is maintained in the form of a circular linked list. So, this is a very common example where we are using circular linked list, that is in operating systems for allocating your processor to the various applications that are running on it. So, also circular linked lists are used for implementation of advanced data structures like the Fibonacci heap. So, advanced data structures, when you will study in your postgraduate, then also you will be using circular linked list. So, these were the simple linked list. Now, this is in my last slide, you will see that this is a typical node in a linked list. You can define it in the form of a class where it will have two objects, which is integer data, and you are having another user defined object node next, which is a pointer, or you can define it in the form of a structure. So, this is an example of a structure. Structure is a user defined data type. So, I have defined one node as a type structure, which is having two fields, integer data and a pointer to the next node, which is again a kind of structure. So, this is what we discussed in the first class, the types of linked list, the basic structure of a node in a linked list, the advantages of a doubly linked list and of a circular linked list. So, in the next class, we have also compared in this class the arrays and linked lists with each other, the advantages and disadvantages of both. So, in the next class, we are going to talk about, we will create a linked list and we will do some insertions into that linked list. So, till then, keep studying and thank you, students.